Sets. Now we are going to the another concept of divide and conquer, that is merge sort, one of the sorting technique. So here of course we know the sorting technique means among a number of elements you need to sort those elements into an order. So those elements which may not be in an order, you need to sort those elements into sorted order. That is a sorting technique. In that we have going for one of the sorting technique, that is merge sort. Now so we'll see what is this merge sort, how it will sort the elements, what is this procedure, everything we will see here. So the first statement that I have given is, given a sequence of n elements, that is of course starts from a of 1 to a of n, the general idea is to find the mid, and that is a middle, then split into two sets. So what is this mid and how you need to split into two sets, that we need to find. So I'll take again here one example so that you can understand better. We'll see this example first. Now I have taken here a set of elements where index starts from 1 to and total number of elements are 10. Here I have taken, of course I need to sort these elements into an order. So now how this procedure will proceed, we'll see here. Okay, so that is an array which is, this is the initial and last element, that is a of 1 to 10 is totally the elements. So it will divide this array into two parts. How it will divide means based on the mid value. So if I take the middle value here, so first plus last by 2, if I take, I'll get the value as 1. So how I am dividing this array? So that is a condition here. If I get the mid value, if I have initial value, mid value and last value, high value, so I need to divide the array into a of l comma mid, so one thing, and the other one is a of mid plus 1 comma high. So like this I need to divide. So if you take this concept, so this is the L value, this is the high value, you will get the mid value as 1 plus 10 by 2, which is 5 you will get. So based on that, if I divide a of 1 to 5, and here the mid value is 5 means 5 plus 1 6, 6 to last value h. So like this it will divide. And again here also a of 1 plus 5 by 2, which is 3. So a of 1 to 3, then 4 to 5. Next a of 1 to 2. Next only one element will be there here, 3 to 3. Here also 1 to 2 means again 1 to 1 means one element, here 2 to 2. So here if you here also 6 to 10 is also the similar way. If you observe here, you are dividing your problem into sub problems like this until the problem is small, exactly with respect to divide and conquer strategy. You are dividing your array into smaller arrays, like you are dividing your problem into sub problems like this until you feel that your problem is small. Why I am feeling that this is small means you cannot divide this further, that is only one element you have. A of 1 to 1 means only one element, you cannot divide further. So that's why this is a small problem. Like this, after dividing, you can see here a of 1 to 1 means first element. What is the first element? 50. Here second element 30. Now after dividing, what you are doing here is 50 30. you are applying the method and you are sorting only these two elements and giving these values to this array. So now 50 30, if I make it into order, it will become 30 and 50. See, instead of I am making this into sorted, I have divided into smaller and I am taking only these two elements and I am sorting. Now here only one element. Now you see in this level you have two elements here, here you have one element. So now 30, 50, 80. If I make it into an order, anyway you will get like this 30, 50, 80. Now the array which consisting three elements in the order, that is 30, 50, 80. If you take here also 4 to 4 means the element, the fourth element 90, fifth element 10. If you make it into an order, now it becomes 10 comma 90. 4 to 5 means only two elements, that is 10 comma 90. Now if you see here three elements, here two elements. If you make them into a sorted order, here it becomes 10, 30, 50, 89. I'll tell you how it will sort, how it will make, which element will come first and which element will come last. So this is a procedure like this in each level it will go. The same thing here also, 70, 20, it becomes 20, 70. Here 40, 20, 40, 70, like this here. And it comes here like this. Now these two sub-arrays again sorted and finally you will get the order here. So I can say this is an order. That is 10, 20, 30 up to 100. So like this it will come. So this is actually the method of MEDSORT. So now we'll go with algorithmic, how it will sort, how it will divide, everything we'll see now. So given a sequence of n elements f1 to n, the general idea is to find mid value. We are finding the mid value split into two sets. You can see two sets. One set is f1 to n by 2 and the another set is n by 2 plus 1, that is mid plus 1. N by 2 means mid only, so mid plus 1 up to n. So like this you are dividing in each time you are dividing it into two parts like this. Now each set is individually sorted, that I explained. Each set is individually sorted, that is this set is individually sorted, this set is individually sorted, like this, and the resulting sorted sequences are merged to produce a single sorted sequence of n elements. The meaning here is, so this set is individually sorted and this one, and this is sorted 30, 50, 80 sorted, 10, 90 sorted. Now these two are again sorted to get this. So that is the thing here he is explaining. So resulting sorted sequences are matched to produce a single sorted sequence of n elements. Thus we have another ideal example of course this is the divide and conquer strategy, in which the splitting is into two equal sized sets and the combining operation is the merging of two sorted sets into one. That means every time if you see this array is sorted, 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 every time it is sorted. Now finally you will get the answer as again sorted one. So this is a procedure that will be applied in MEDSORT using divide and conquer strategy. Now if you go to the algorithmic part, so how we need to write an algorithm. So this is the algorithm. So this MEDSORT algorithm will have two procedures, not only one procedure, two procedure. One procedure name is MEDSORT and the another procedure name is merge. See, merge sort is a one procedure and merge is another procedure. I'll show you what is merge. Merge is this one. So this is a merge procedure. This is a merge sort procedure. Combinedly, you will get the answer for merge sort algorithm. So of course, this merge sort procedure is a recursive. You are calling recursively here. So this is a merge sort procedure. We'll see this one. I'll explain this one by an example. Whatever the example we have taken in the previous, based on that I'll explain here. So first, merge sort of low comma high. What will be my low value? Here if I take low value is 1 anyway, high value is 10. Now of course it is a global array to be sorted. Small of p is true. When it will be true? If there is one element exists. That is only we have done now here. At the end, if it can consisting only in one element, then I can say it is a problem is small. So in this case, the list is already sorted. That means only one element, no need to sort. If low is less than high, so you need to proceed like this. What you need to proceed, you can see here. Divide the problem into sub-problems, find way to split the set. So you need to divide the problem, way to split. So I need to get the splitting criteria, that is by finding mid value. By finding mid value, if I find the mid value, I can split. So I found here the mid value as 5 here. Somewhere here mid value as 3, that's why I'm splitting into f l comma mid and mid plus 1 comma high. For that I'm dividing it into two parts. So I'm finding mid value, then solve the sub problem. Now what I am doing here, merge sort of low comma mid, mid plus 1 comma high. What is the meaning here? So here you can see, so if this is an array, so here you can see a of low comma mid, mid plus 1 comma high. So all this sub procedure has to be again solved. So this is the recursive procedure. Here we need to apply and combine the solution. So how to combine the solution? Merge low, mid, high. So what happens here is, in the merge, I'm telling about merge procedure. So if you take here a of 1 2 3 3. So what is the low value here? 1. What is the high value here? 3. What is the mid value here? 2. So the mid value is 2 here. If you take this one, low value is 1, high value is 5, mid value is 3, because this is the mid value, low comma mid, mid plus 1 comma high. Like this I need to do, and I am merging this. See what happens when I merged. This is the array 1 to 2, 3 to 3, it becomes 1 to 3. Here 1 to 3, 4 to 5, it becomes 1 to 5. So like this, 6 to 8, 9 to 10, it becomes 6 to 10. So like this we need to merge it. So this is a concept of merging here. Now this is the dividing part. So how you are dividing into equal, that I explained here. That is a 12th line and 13th line, how these levels are divided like this. So that explained with this 12th and 13th lines. Now the procedure merge low, mid, high means, so if I have 30 50, let us take 50 30 here, how it become 30 50. If I have, let us suppose 90 10, how it become 10 90. Here I have 30 50 80 and 10 90, how it become 10 30 50. So that is explained here with this merging two sorted subarrays. So anyway, if I take these two, of course for these two merge procedure is applied, and of course these two merge procedure is applied, and of course these two. So what I will do now here is, instead of explaining everything, I'll explain only this one and this one, so that you can understand better, because this is having more number of elements. That's why it is better for you to understand. So I am taking only these two, and how it will become like this sorted. So I am taking these two parts, that is this array is sorted one, this array is sorted one. So if I merge these two, how it will become, I'll explain with this. So I have written here 10, 30, 50, 80, 90 one side, and the 20, 40, 60, 70, 100 and other side. Now we'll say this algorithm. So algorithm merge low, mid, high. So what is the low value here? Low value is 1 only. High value is of course 10 only. Mid value 5. Now what I will do is, of course, global array containing two sorted subsets, that is low, mid, low comma mid, this is, and mid plus 1 gamma high. The goal is to merge these two subsets into a single set residing at low comma high. So now we are taking some auxiliary array, that is B array. So I'll tell you why it is used. Now this is an auxiliary array B. We'll see what happens here. Now h equals to low. H equals to low means what happens to low value, that is, I'll write here itself 1. So L equals to low, L value is also 1, not L here, this is I, and J equals to mid plus 1, that is 6. So I value is 1, J value is 6. What is the meaning here is, so of course this is the index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what it means is, I starts from the first array index of the first element of first array. J starts from first element of the second array. So I value is from first array, J value is from second array. That's the first element. Now H is less than or equals to mid, J is less than or equals to high. So you need to proceed this until all the elements. So what is the meaning here is, all the elements, if you complete in first array, this condition will be false. If all the elements in the second array are completed, then this condition will be false. So we'll say this: if A of H is less than A of J, that means H means 1. So A of H, what is A of H? A of 1, 10. 10 is less than A of J, A of 6. 10 is less than 20. Now the first condition is 10 is less than 20. If it is true, what you are doing, H equals to H plus 1. So now what you are doing here is, I'm writing here H equals to initially 1. Now H value I am incrementing, and at the same time what I am doing, B of I equals to A of H. So B array, this is B of I value is 1, so I'll make it 4, 5, 6, 7, 8, 9, 10. So B of 1, B of 1 equals to what you are putting, A of H. What is that value? 10 you are putting. Okay, now this is over. If condition is true, anyway else part it will not go, and this is while condition, again it goes for here, I equals to I plus 1. Now I value will become 1 is over, so I'll write I value is 1. Now it will become 2. Now of course J value is 6 here. Now going to that, J value is 6, of course less than, condition is true. if A of h, what is A of h? Now h value is 2. What is A of 2? So now 30 is less than 20. No. So it goes to else part, where B of I, that is B of 2, is equals to A of j. What is A of j? J is 6. So what is there? 20. Now it will insert 20 and immediately increasing the j. So now you can observe what happens here is it is checking 10, 20, which is less than it is putting here. Now it is checking incrementing. So I am putting 10 means it is incrementing the index of the first array, that is 30. Now compared with 20, 20 is greater. 20 you are putting. Now you are putting 20, that's why you increment the j value. Now 40 it comes. 30, 40. Which is the least one? 30. It will come in the next one. That is, you can see here. Again, if you go here, A of h, h means 2. So that is 30 is less than A of j, 7, 40. 30 is less than 40? Yes. So B of I equals to here. So 30 will be placed here. Okay. Next you will get 40. Next you will get 50. So next you will get 50. See here, 50, 60. You will get 50. That means h value will become, of course, here 3. Then j value will become 8. Next 3. 50 is over. No, 50 is over. Then it will check for 4. So 4, 80 and 60. That is 60 only. Next, that is 8 will become 9. Now h of 4, 80 is there, 70 is there, which is the least value? 70. Now 70 has to be placed, and now here it becomes 10. Now here you can see 4, 80 and 100. So 80 will come here. Next h value will become 5. 90 and 100. So 90 will come here. And then 100, the final one. See, like this it will happen and up to here. Now the concept here is if h is greater than mid. So what is the logic here is if h is greater. What is the logic here? H value is going like this. Now mid value is 5. Now h is greater than mid. When it will become? If the all elements in the first array are completed. So what is the conclusion here is if the elements of the first array are completed, whatever the leftover elements in the second array, we can place directly here. Why? Because all the elements in this are sorted. So one element is present. That's why you can place the element directly here instead of again sorting, searching. And in reverse also you can say if this condition, else means that means this condition. If this array is completed, whatever the elements here left over will be directly submitted to this array B. So that is a concept of this condition, that is this if else condition. If h is greater than mid, then for k equals to j to high, whatever the elements are there, all directly you can place. Else for k equals h to mid, that means h to mid means this one. So whatever the elements are there, you can directly place. So like this if you proceed, you will get all the elements which in B auxiliary array are sorted order. So now after doing this, B is an auxiliary array we have taken, but our original array is A only. So what we are doing in the line of 30, all the elements which are there in B are copying to A sequentially, that is k equals to low to high you are merging, and a of k equals to b of k. So now in a of it becomes a in also, in b also, and in a also you will get the elements in sorted array. Now finally you are getting the values of a here. So this is the concept of merge sort. So what is this merge sort? We'll quickly revise. So elements to be divided into two sets until the problem is small. How to divide? That is the algorithm. You can use merge sort, where low comma mid like this you need to divide, then you need to merge. How you need to merge is according to this one. Here you will take one auxiliary array, and then you are checking one element in the first element in the one array, first element in the second array, which is the list that you are placing into the auxiliary array. So next you are checking the next element and the previous element which is not submitted into B array. So like this we'll complete all those elements, and finally after getting all the sorted elements into B, now you are copying those elements into A. So this is a procedure of binary search. Thank you.